Welcome. I am so thrilled you're joining us today.
Yeah, we have a really fantastic one lined up.
We really do. Whether you are prepping for a big technical architecture meeting or looking to level up your engineering skill,
Or, maybe you're just insanely curious about how complex digital systems are actually built behind the scenes.
exactly. You are in exactly the right place. Today, we have a really special deep dive planned for you. We're looking at a brilliant piece of writing by technology writer Aaron Rose.
Yeah, it was published on tech-reader.blog.
Right, and it's titled The Secret Life of Python, The Blueprint.
It is such a fantastic piece of source material. Aaron Rose really has this gift for taking these abstract, sometimes really intimidating software engineering concepts
And grounding them in human stories.
yes, highly relatable stories that immediately make you understand the stakes of what we're actually building.
And our mission for you today is a big one. This deep dive isn't just going to be about Python code,
No, not at all.
or syntax, or dry technical rules. We are going on a journey to explore a fundamental mindset shift. We're looking at how you transition from being a simple coder
Right, someone who just writes scripts to get things done.
to becoming a true architect. We are going to learn how to manage massive, heavy, complex resources in your systems by completely separating the intent of creating something from the actual action of building it.
It's a massive shift in how you think about problem solving.
It really is.
Yeah.
Okay, let's unpack this by setting the scene with the story Aaron Rose uses to open the article, because it starts with a scenario that feels painfully familiar.
Painfully is the right word. The article starts with a narrative about a coder named Timothy. And Timothy is having a genuinely terrible day.
The worst day.
He is sitting at his desk, staring at a printed stack of messy code, and his brow is deeply furrowed. He is completely stressed out, dealing with the psychological fallout of what the article calls the uncopyable disaster.
I have absolutely been a Timothy at some point in my career.
Oh, I think we all have.
I remember bringing down an entire staging server back in, I think, 2018, because I tried to brute force a database connection in a very similar way. It's practically a rite of passage for developers to accidentally blow up a system because they misjudged how heavy a piece of code really was.
That shared trauma is exactly why this story works so well. Prior to this moment of staring at his printed code, Timothy was working with a live database connection.
Right.
And in the programming world, a live database connection is what we call a heavy object.
Which means it's not just a simple variable.
Exactly. It's a resource that takes up a large footprint in your computer's memory. It requires significant network power. And crucially, it is actively communicating with another physical server out there in the real world.
It's an open pipe. And Timothy, in an attempt to be efficient and reuse this connection across different parts of his application, tried to use a specific Python command called deep copy on it.
Which is where everything went wrong. To understand why, we need to quickly break down what deep copy actually does behind the scenes. When you tell Python to deep copy something, you are instructing it to recursively clone every single tiny piece of that object in memory.
It wants to create an exact independent twin.
Yes. But a live database connection isn't just static data sitting in memory. It is a literal open tube of data streaming back and forth from another computer.
You can't just clone an active network socket that leads to an external server.
You can't. Python recognized that impossibility and completely panicked, crashing Timothy's entire system.
And because he is completely terrified of causing another massive system crash, Timothy has overcorrected. He swung the pendulum entirely in the opposite direction.
Right, no more copying for him.
Instead of trying to cleverly copy things, he is now manually passing his database host names, his network ports, and his usernames everywhere throughout his code.
His code base has turned into a scattered, sprawling mess. If he needs to change just one single setting, say, the IT department updates the name of the database server.
He has to hunt that string of text down and manually update it in 15 different places across his scripts.
He has traded the immediate danger of system crashes for the slow, agonizing death of administrative chaos.
But this is where the narrative shifts. A second character enters the scene. Margaret, who is clearly his senior mentor, approaches his desk. And she brings two very important things to the rescue.
A fresh tin of biscuits and a whiteboard.
What's a mentorship moment without biscuits?
What's fascinating here is how Margaret diagnoses Timothy's exact predicament. She doesn't just look at his code and scold him for bad syntax or sloppy variable names. She looks at the underlying philosophy of his approach.
She gets to the root cause.
Yes. She tells him that he is suffering from the construction site problem.
Construction site problem. Margaret explains that Timothy is trying to move an entire, fully finished building every single time he needs something. He wants a new database connection, so he's trying to pick up a completed skyscraper and drop it somewhere else. He's dragging the completed, heavy resource around with him everywhere he goes in his code.
And we see this all the time in software development. People drag the completed object around because it feels tangible. It feels like you've accomplished something.
You built the connection, so you want to hold on to it.
Exactly. But Margaret draws a very different picture on the whiteboard to illustrate why this is a trap. She draws a completed, finished house.
And that finished house represents the live database connection. It's the heavy object. It has plumbing connected to the city water lines. It has electrical wires tied to the grid.
Right.
If I pointed to a physical brick-and-mortar house on your street and said, hey, can you just run that through the photocopier for me? You would think I had lost my mind.
I would. You cannot photocopy a building that is physically tethered to the earth.
It's exactly why Python refused to do it for Timothy. Python told him it was impossible to photocopy a heavy object tethered to the real world.
But Margaret doesn't stop there. Next to the heavy finished house, she draws a detailed architectural diagram, the blueprint.
And the blueprint is just a piece of paper. It's entirely lightweight. It's just pure data, pure information. It takes up virtually zero physical space.
This is the critical distinction we want you to grasp today. The blueprint is not the house. The blueprint is simply the instructions for the house.
Right.
It represents the intent. It's a collection of facts about how the house should be built when the time comes.
Because it's just a piece of paper, you can safely photocopy that blueprint a million times. You can pass it around to anyone on your team. You can email it. You can stuff it in a drawer.
Yeah.
And whenever someone actually needs a house, they just take that lightweight blueprint and they use it to build a fresh, brand new house right there on the spot.
Wow.
Building the house is the action.
You store the intent, and you execute the action only when you absolutely need to. This separates the knowledge of the thing from the burden of the thing itself.
Here's where it gets really interesting, because Margaret doesn't just leave Timothy with a nice philosophical drawing on a whiteboard.
No, she actually shows him how to do it.
She shows him how to translate this exact concept into actual system architecture by introducing him to the builder pattern. But wait, I have to play devil's advocate for a second.
Go for it.
When I first read this section, my immediate thought was, isn't Margaret just giving Timothy more work? Creating a whole new factory class just to make a database connection sounds like a lot of extra boilerplate code. Isn't it faster just to write the connection string where you need it?
That is the exact trap that keeps coders from becoming architects.
Okay, tell me why.
Yes, in the very short term, for a script you're going to run once and throw away, just writing the connection string is faster. But we are talking about complex systems here. Writing it directly is like building a custom house with no blueprints every time you need shelter.
Which is exhausting.
Exactly. The builder pattern requires a small upfront investment in writing that factory class, but it eliminates the massive technical debt of tracking down scattered configurations later. It pays for itself the very first time you need to scale up or change a server address.
That makes perfect sense. So let's look at how Margaret and Timothy actually build this factory class, which they name Database Blueprint. For those who might not breathe Python every day, think of a class as essentially a manila folder that holds your recipe and the tools needed to cook it.
The Database Blueprint class works in two distinct halves, perfectly mirroring the whiteboard drawing. The first part is entirely about storing the intent.
Okay.
In the code, the blueprint safely stores the configuration data. It holds the simple, lightweight text, the hostname of the database, and the username. It simply remembers the instructions.
And there is a massive security pro tip included in this part of the source material. When they are storing the configuration data, the host and the user, they also need to handle the database password.
Crucial step.
But Margaret makes sure they do not just type the password directly into the blueprint code. Instead, they use a command, os.getinv, and then pass in db_password.
We need to pause on that because understanding why they use an environment variable is crucial for anyone building modern systems.
It really is.
Hard coding a password, meaning typing the actual secret text directly into your script, is arguably the biggest security sin you can commit. If anyone ever looks at your code repository, or if you accidentally share your code on a site like GitHub, your secret password is just sitting there in plain text for the whole world to steal.
It would be the exact equivalent of writing the combination to your safe on a bright yellow sticky note and slapping it on the front door of the bank.
A perfect analogy. By using os.getIndave, which reaches out to the operating system's environment variables, they are essentially telling the blueprint, I am not going to write the password down on this piece of paper. But when it's time to actually build the house, you can go look inside a secure, locked vault outside of this script to find the password you need. It keeps the blueprint totally safe to share and version control, while completely eliminating the risk of exposing credentials.
So the intent is safely locked away in the blueprint, along with a secure map to the password. But instructions on a page don't do us any good unless a construction crew actually shows up. How does this blueprint actually build the connection?
This brings us to the second half of the builder pattern executing the action. Inside that blueprint class, Margaret adds specific function, or what we call a method, named .build. This is where the heavy lifting happens.
The blueprint just sits there, completely harmless and lightweight, passing through the code without consuming memory or network resources. But the second you call that .build method, it springs into action.
Whenever the system decides it needs a new, live connection to the database, it simply calls .build. That method takes the lightweight configuration data it has been holding on to, it grabs the password from the secure environment variable, and it reaches out to the real world to spin up the heavy resource.
It returns a fresh, live connection exactly when and where it is required.
The result of this architecture for Timothy is nothing short of a revelation. He realizes he doesn't need to pass host names and ports everywhere anymore.
No more scattered text strings.
He doesn't need to update his settings in 15 different files. He just makes one single centralized blueprint. Let's say he calls it his production_db blueprint.
He can safely pass that one production_db blueprint around to every corner of his application. It never crashes the system if he copies it, because he's just copying the instructions.
Exactly.
And think about the scalability here. If his application suddenly gets featured on the front page of a major website and needs 10 separate database connections to handle a massive surge in traffic, he doesn't panic.
He just takes his single blueprint and he calls .build 10 times. 10 fresh, perfect, untangled live connections, all generated from one single source of truth. No scattered settings, no system crashes.
The source text beautifully captures the psychology of this moment. Timothy looks at his mentor and he says, I feel like I'm not just writing scripts anymore. I'm actually designing how things are made.
That is such a satisfying payoff for the character. It's the realization that he is no longer just reacting to the code, he's commanding it.
Yeah.
If we connect this to the bigger picture, Margaret's response to him highlights the entire thesis of the article. She tells him that this feeling is because he has transitioned from being a coder to being an architect.
Let's really dig into that psychological shift, because I think this is where the deepest value of Aaron Rose's article lies.
Sure.
Why is it so easy to get stuck in the coder mindset?
It comes down to the dopamine hit of immediate action.
Oh, that makes sense.
A coder focuses entirely on the objects in front of them because it feels highly productive to just write a script and see a database connect immediately. A coder brute forces the objects to try and make them do what they want, even if it means dragging a heavy connection through 50 lines of code. It's a reactive mindset. You have a problem, you write code to hit the problem with a hammer.
But an architect operates with strategic patience. An architect understands that in complex, evolving environments, the absolute most powerful thing you can hold on to isn't the finished object itself.
It's the knowledge of how to create it. Storing the knowledge of creation, the blueprint gives you infinite flexibility. You can delay the creation until the exact optimal moment. Storing the finished object just gives you a heady burden you have to carry around, maintain, and protect from crashing.
To make sure this fundamentally cements for you, the listener, Aaron Rose includes a brilliant summary section at the end of the post called Margaret's Cheat Sheet. It strips away the narrative and gives you the pure architectural rules. Let's walk through it.
Sounds good.
First, she outlines the problem.
The problem is clear treating heavy objects like database connections, network sockets, or open files as if they were simple data causes massive instability and system crashes.
Second, the metaphor. Don't photocopy the house copiation. Photocopy the blueprint. Separate your intent from your action.
Third is the pattern itself. You implement this by creating a blueprint or a factory class. That class securely stores the configuration, which is your intent, and it possesses a .build method to actually create the resource, which is your action.
Fourth, she compares the before state of Timothy's world. Before utilizing the builder pattern, a developer suffers from scattered configurations, dangerous copying attempts that lead to panics, and massive security risks from hard-coded passwords.
And fifth, The after state. By thinking like an architect, you gain centralized blueprints, the ability to generate fresh resources perfectly on demand, and bulletproof credential handling through environment variables.
That brings us to the sixth and final point on Margaret's cheat sheet, which is labeled Beyond Databases. Aaron Rose explicitly notes in the text that the builder pattern is not just some niche trick reserved for database connections. This pattern applies to literally any heavy object you might encounter in your digital systems.
Yeah, this is huge.
I really want to spend a minute here because this is where the concept scales up to massive enterprise systems.
It's incredibly versatile. Consider complex API clients. Let's say your application needs to talk to the Stripe API to process payments or the Twitter API to pull real-time data. An API client is a heavy object. It often requires negotiating secure OAuth tokens, establishing session limits, and managing connection pools.
You definitely do not want to instantiate a massive, fully authenticated Stripe payment client at the very beginning of your application and drag it through every single function just in case someone buys something.
Right, that would be incredibly inefficient.
You pass the lightweight Stripe blueprint around. Then, at the exact millisecond, a user clicks checkout, you call .build, authenticate the fresh session, process the payment, and close it down.
The text also specifically mentions machine learning models, which is incredibly relevant today. Think about a modern large language model or a complex PyTorch image recognition model. These are massive files, sometimes tens of gigabytes in size, that require huge amounts of GPU memory to run.
Oh, absolutely. If you try to load a 40 gigabyte machine learning model into your system's memory and then pass that active model around between different web requests, your server is going to melt down almost immediately.
Precisely. You simply cannot treat a machine learning model like a normal variable. Instead, you create an ML model blueprint. It stores the file path to the model weights on your hard drive. It stores the configuration for how many GPU cores it is allowed to use, and it waits.
It just holds the intent.
Exactly. You pass that tiny, bite-sized blueprint to your processing queues. Only when a piece of data arrives that actually needs to be analyzed do you call .build. The system loads the heavy model into memory, does the math, and then clears it out.
This raises an important question. What stands out to you about how this changes the way we approach problem solving? Think about the systems, the code bases, or the tech stacks you work with every single day. Are you secretly Timothy? Are you trying to lug around finished houses, dragging heavy, brittle resources through your code, or are you utilizing blueprints to keep your architecture light and flexible?
It's a question every developer needs to ask themselves.
So what does this all mean? Let's bring everything we've discussed today together.
Yeah.
The ultimate takeaway from Aaron Rose's article is that separating your configurations from your actions doesn't just make your code look a little bit cleaner on the screen. It is a fundamental shift in design philosophy.
Yes.
It's a shift that makes your systems infinitely more scalable, highly reliable, and far more secure. By embracing the builder pattern, you stop reacting to system failures like a stressed-out coder playing whack-a-mole with errors, and you start designing robust, intentional solutions like a true systems architect.
It's about recognizing that intent and action are two very different phases of a system's life cycle. Tangling them together is exactly what causes friction, errors, and those catastrophic, uncopyable disasters. Keep your instructions pure and lightweight, and only incur the heavy cost of action precisely when and where it is needed.
Before we go, I'm going to leave you with a final provocative thought to mull over. We have spent this entire deep dive talking about Python and code and database connections, but let's take the absolute core theme of Aaron Rose's article and apply it to the human world. Margaret notes that the most powerful thing you can hold on to is the knowledge of how to create an object rather than the object itself.
Which is a beautiful concept on its own.
Think about your own daily life. Think about your workflows, your business processes, or even your personal projects. How many heavy objects are you stubbornly dragging around? How many rigid, completed tasks or overly complicated finished projects are you trying to clumsily duplicate when you face a new challenge at work?
I know, I'm guilty of that.
What if, instead of trying to copy the final result of your last success, you isolated the lightweight blueprints of that success? What if you documented the exact steps, the pure intent, and the flexible process? That way, whenever your environment changes or you face a brand new problem, you don't have to drag the old baggage with you. You just pull out the blueprint, adapt the configuration, and build a fresh, perfectly tailored solution right there on the spot.
That is a profoundly useful way to look at it. Becoming an architect isn't just about writing better code, it's a framework for navigating the world. It's about valuing the process and the knowledge of creation just as highly as the final creation itself.
We want to thank you so much for joining us on this deep dive today. We hope this exploration of the builder pattern, the disaster of copying heavy objects, and the mindset shift from coder to architect has sparked some new ideas for you. Keep examining your own systems, keep asking those big architectural questions, and most importantly, stop trying to photocopy finished houses. Go build some blueprints. We will see you next time.